Okay, so electric potential at a point. Do you remember the definition? There were these two concepts that we had studied: electric potential and potential difference. Sorry, potential energy.
Yeah, I think electric potential was the amount of like work done needed to move a unit charge from infinity, right?
Yeah, electric potential was work done per unit charge by any external force to bring
Okay.
it from infinity to a point. Yeah. So the important keywords are work done, uh, per coulomb charge, then positive charge, okay, from infinity, the 0 point, all right, to any point in space. You'll get 2 marks for these keywords. Okay. Then a charged particle is accelerated from rest in a vacuum through a potential difference V. Show that the final speed V of the particle is given by the expression. So now this capital V basically is the potential difference by which the particle is accelerated. Initially, the particle is at rest, okay, and it's in vacuum. There's no air resistance. V is the potential difference, and show that the final speed V of the particle is given by this expression. In this expression, Q is charge, M is mass, where Q or M is the charge to mass ratio, and V is the velocity. So how should we start with this one here? Yeah, hasn't any idea?
No idea. Actually, मैंने कूलम लॉ तक पढ़ा था, मैंने पोटेंशियल वाला अभी पार्ट नहीं था रीड किया.
Okay. All right. So let's figure this out. You list down for this type of question, you should obviously first of all be listing the quantities down. Okay. Just see what quantities are there. So if you read through this question, that basically they've given us potential difference. The expression has V, which is the potential difference, the voltage. Um, then there is the speed V that you're supposed to find. There's mass, and then there's charge to mass ratio. Okay, and you're supposed to figure out V. So there has to be. So you need to obviously be selecting a mix of formulas to make V the subject of the equation. Let's recall the formulas that we've studied throughout the course of electric potentials. तो उसमें kinetic energy, देखो whenever a particle is moving, so it will have a velocity, right? And because of that velocity, it will undergo certain energy changes. So there will be a gain in kinetic energy, which will be equal to change in potential energy of the object. Can we say that? Yeah. Kinetic energy gain. One second. I will have to use my whiteboard for this because the annotation is not working fine. So just hold on. Okay, so Hassan, I was explaining there has to be a change in kinetic energy, which will be equal to the change in potential energy. You get this, right? Because we're talking about a moving object. So if you remember, while discussing potential energy, I told you that QV is the formula, the basic formula for potential energy. Is Q times V, where Q is charge and V is V. This is capital V, okay? This is the voltage potential difference. So QV is equal to potential energy, and then half mv squared is equal to the kinetic energy of the object. Now, if you make this V square the subject, you're gonna get 2 multiplied on the other side, okay? 2 mv qv, sorry, m will be divided here and root on both sides. So v is equal to 2vq by m under the
I
root.
can't view the screen. पता नहीं screen नहीं आ रही है. Can you see the past paper वाला page?
Hold on, let me again change. Now can you see both the screens?
Yes, I can see the screen now.
So let me explain this again. Kinetic energy is equal to potential energy. Kinetic energy is half mv square. Potential energy here is vq, where v is the voltage and q is the charge. So if you rearrange this formula, v square is equal to 2vq over m, root on both sides. V is equal to under root 2vq over m. See, we've gotten the form here, right? Clear with this, Hassan?
Yes, it's clear.
Okay, moving on. So a particle with specific charge 9.58 times 10 raised to the power of 7 coulombs kg negative 1 is moving in a vacuum towards a fixed metal sphere. So you're given with charge of a particle, you're given charge to mass ratio again. Okay, yeah. So you see, this is how did I extract it? This is charge to mass ratio, not just charge, because this kg negative 1. There's charge over this coulomb, it's basically coulomb over kg. So this is charge to mass ratio that's given. And this is the velocity. And here, this is the potential of the other object. And the objects are moving, the first object is moving towards the second object. The initial speed of the particle is 2.5 times 10 to the power 5 meter per second. We just wrote that when it is a longer distance from the sphere. The sphere is positively charged and has a potential of 470 volts, right? Use the expression in B, the one that we just wrote, to determine whether the particle will reach the surface of this sphere or not. Okay, you need to, obviously, you'll see whether this particle will touch the sphere or no by using the original equation. So for this one here, what we can do is, okay, let's write down the formula that we just made. V is under root 2vq over m, right? Where V is the potential. So should we figure out V first of all? Take, if we, let's say, get the value for voltage, the potential difference, we'll see whether the potential of this particle, देखो, if let's say we figure out a value for V here, so we'll know, will that voltage be able to compete with this one here, which is 470 volts? So agar to the answer will be, let's say, lesser than 470 volts, then the object will not reach the surface of the sphere. If the potential is 470 or greater than 470, in that case, this particle would be able to touch the surface of the sphere. Do you get this?
Yes, I get that.
That's, we'll have to figure out the potential. So for potential, you're gonna simply use the formula, same one, you know, the velocity. So let's first of all make V, the potential, the subject. So you're gonna take square on both sides. V square is equal to 2vq over m. Then mv square over 2q is equal to voltage. This is the formula that we're going to take forward now. M is mass over charge. So if we, let's say, put 9.58 times 10 to
Yeah,
the power of 7, sorry.
I said you're going to use the ratio 9.58 now, right?
Yeah, we're going to simply use it in place of m over q. So m over q to gya, so we'll simply write 2 underneath this and we'll multiply it with the velocity squared. 2.5 times 10 to the power of 5 square is equal to v. You can use your calculator. Can you let me know what the answer is now?
It's over 2, right?
Yes.
It's 2.99 into 10 is per power 18.
Sorry, come again.
I'm gonna type it.
That is not possible. So I just do the calculation again. Wait, hold on. Are we using the
Wait, I
formula
think like you
correctly?
use the ratio wrong because like
Yeah.
question can Coulomb over mass. This is
Mm-hmm.
mass
Sorry.
over charge.
Sorry. Yeah. So, correct. It should be 2.5 times 10 to the power of 5 whole square over 9.58 times 10 to the 7 times 2 equals V. Yeah, this is the correct one. This is times 2. Now we should get the correct one.
Is it 326.2?
Should be 326 something. So if we let's round it off to 330, 330 volts is still lesser than 470. The
It's not
concluding statement
great.
will be that no, the particle will not reach the surface of the sphere. All right. Now we'll discuss. Let's look at question number 5. So question number 5 states that a small charged metal sphere is situated in an earthed metal box. So the box is earthed, right? There's negative charge flowing through this earth. It illustrates the electric field between the sphere and the metal box. The field lines move from positive to negative, so this indicates that the metal sphere is positive because the lines are moving outwards towards the surrounding. By reference to figure 4.1, state and explain whether the sphere is positively charged or negatively charged. We just made that inference because the lines are moving from the sphere and the field lines travel from positive to negative. The sphere is supposed to be positively charged. All right. Part 2, why it appears as if the charge in the sphere is concentrated at the center of the sphere. So why do you think it acts as a point charge? And the reason for that is because all of the lines, they appear to radiate from center. Yeah. So that is where the entire charge is concentrated. Okay, we're just studying the diagram here. Figure 4.1, draw an arrow to show the direction of the force on a stationary electron situated at point A. तो इलेक्ट्रॉन और इस फोर्स में ये है कि Lanesh, so this is positive charge and this is how the charge actually touches the negative plates. The plates are negative. And there's an electron that's situated here. So how would the electron move? Where would the electron go? The electron must go from negative to positive, yeah?
Yeah, it's gonna
So
move towards the positive charge.
yeah, it's gonna move towards the charge, but how? What should be the direction? Okay, we know the direction. Which path should the electron be taking? And how should you figure out the force there? There's one thing we've established that force, do you remember the formula for electric fields? E is,
Electric.
field
field
strength,
strength.
F over
If
Q, and
double
E is,
charge.
yeah, V by D. So electric field strength is supposed to be force per unit charge. And electric field strength is also velocity, potential difference over distance. तो सबसे पहले तो if let's say an electron, the electron must travel straight up to the positive charge. So the lines are going to act as tangents to the fields there. Okay. If let's say an electron is placed here, so it's going to travel in a straight line towards the positive charge. And the trajectory of this electron will be a tangent to this curve of the electric field. Okay. This point A, by the way. Okay, if this is point A, so this is how the electron moves. All right. The radius r of the sphere is 2.4 centimeter. The magnitude of charge q on the sphere is 0.76 nanocoulombs. Use the expression to calculate a value for the magnitude of the potential V at the surface of the sphere. Okay. So it's very simple. You're going to simply plug in the values there. You know the radius, you know the charge, okay? But you need to be careful. You have to convert this nanocoulombs into coulombs first of all. Yeah.
Yeah. Nanocoulomb is like power 9, right?
Yeah. So 0.76. ये हो जाएगा. Let me just also write this here. 0.76 times 10 to the power of minus 9 divided by 4 pi. Epsilon permittivity of free space is 8.85 times 10 to the power of negative 12 times radius, which is, you need to convert it into meters, 0.024, and then you'll get the answer. Simple. State the sign of the charge induced on the inside of the metal box. Hence, explain whether the actual magnitude of the potential will be greater or smaller than the value calculated. Number one, the negative charge will be induced inside of the box. Yeah. So, so what do you think? Will the potential be greater or smaller than the value that you've calculated in part one? So part one, assuming you're getting a value for potential here, okay, maybe 200 volts to 50 volts, maybe. So if you
Uh,
look at,
it's directly proportional, so depend करता है अगर वो increase करेगा, so it's gonna increase too, right?
mhm. So okay, so what's your final statement there? Will the potential be lower?
I think it's going, isn't it going to be greater?
Why?
I think उन्होंने sign clear नहीं किया.
Look at the work done. Do you think the work done is lesser or greater? Because the work done is lesser. We're talking about a point charge here, okay? And because there's less work being done, the potential will also be lesser than the actual magnitude, of course. Okay?
Wait, can you repeat the work done? वाला screen
Yeah.
stuck तो नहीं होगी? Because I
नहीं
think
नहीं नहीं
screen's
नहीं 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 stuck नहीं
right
होगा.
through. So work done किधर लिखा हुआ है? Like it's less.
Work done कहीं लिखा हुआ नहीं है. This is an inference that we're making now. कि देखो, हम जब when we talk about this charge here, so since it's a point charge, तो अब आपने you need to move from this point, maybe just point where the charge is located, and let's say this is point of infinity. Okay. and you're moving at any other point, maybe yeah, this is point A. इधर तक आप आ रहे हो from infinity to this point. तो point charge है, work done तो कम ही होगा ना, क्योंकि you don't exactly, there's so many other directions of movement here, right? E is equal to F over Q. और यहाँ पे जब हम फोर्स की बात करते हैं, अच्छा वैसे आप जब आगे जाके स्टडी मैग्नेटिज्म उसमें you'll see किस तरह से चार्जेस में फोर्सेस को निकाल रहे होते हैं। अभी के लिए बस ये समझ लो कि क्योंकि पॉइंट चार्ज की वजह से इस पर वर्क डन इज लेसर, and because work done is lesser, again moving from infinity, this is the point of infinity and this is the actual point we're talking about, the potential is also lower and the charge is
Okay.
negative, the induced charge
Oh,
inside box is negative.
ठीक है.
अगर ये स्टेटमेंट आ जाती है कि इंड्यूस चार्ज नेगेटिव है, we're looking at the potential lines, that's it. The reason why, this is the reason why the lines are moving towards the box. A lead sphere is placed in a lead box in free space in a similar arrangement to that shown in figure 4.1. So assuming that the sphere is also made of lead, the box is also made of lead. Explain why it is not possible for the gravitational field to have a similar shape to that electric field. Because gravitational field is always attractive and the field lines are directed towards the box and the sphere, both the box and the sphere, yeah. So they're always attractive forces. Simple. This is the difference between electric and gravitational fields.
Can you repeat that?
Yeah. So I was saying that the reason why the gravitational fields will not behave in a similar manner to electric fields is कि electric तो repulsion attraction दोनों होती है ना, gravitation is always attractive and the field lines will not just only act on the box, they'll also act on the on the sphere, yeah. क्योंकि
Oh,
gravity है वो
okay.
तो दोनों objects को pull करेगी ना.
हाँ, ठीक है, ठीक है.
ग्राफ को देखा जाए एक बार. अच्छा. Question 7. Question 7 is about electric potential. Now, again, define electric potential, work done in bringing positive charge from infinity to a point. Two small spherical charge particles P and Q may be assumed to be point charges located at the centers. The particles are in a vacuum. Particle P is fixed in position. Particle Q is moved along the line joining the two charges. So Q can move. Q can either move closer to P or move away from P. P is a fixed charge. The variation with separation x of the electric potential energy of particle Q is shown. So now if you look at this graph shows the movement of particle Q and the changes in electric potential energy alongside its distance. So as the particle covers distance, मतलब अगर 4 times 10 power minus 10 से it moves towards 14, so you can see the changes in the electric potential. Okay. State how the magnitude of the electric field strength is related to the potential gradient. Electric field strength, how is it related to the gradient? Electric field strength is V over D, potential over charge, right? Y by X. Look at the y-axis, it's potential. The x-axis is distance. So electric field strength is the gradient. You get this? You can make this conclusion here. Okay, the relation
Negative
is
charge
that
to
the
Q.
electric field strength itself is the gradient. Okay.
Yes, yes, clear.
Use your answer in part 1 to show that the force on particle Q is proportional to the gradient of the curve. Okay. Answer to V by D था. क्योंकि electric field strength is proportional to force on Q, to force on Q, तो इसका मतलब ये है कि जो potential gradient है, it should also be proportional to the gradient of the graph. So the force should be proportional because देखो E is F over Q, right? And if by looking at this formula, you can establish the relationship that E is directly proportional to F. And since E is the gradient, the gradient should also be directly proportional to F. Hmm? Hassan, do you get this?
यस यस यहाँ तक समझ आ गया.
ठीक है, इसीलिए हम ये कह रहे हैं कि gradient is directly proportional to difference. अच्छा, before, sorry. Now, the magnitude of the charge on each of the particles P and Q is you're given the charge. Calculate the separation of the particles at the point where particle Q has electric potential energy equal to A. So you clearly are supposed to use the formula for electric potential energy. Electric potential energy was, you remember the formula? Q1, Q2 over R.
और pi and that value and r. पहले हम r को सब्जेक्ट ना बना लें इसमें.
K भी आता है, सॉरी, हाँ. आप R को बना लें सब्जेक्ट, आपको एनर्जी गिवन, आपको पोटेंशियल एनर्जी गिवन है, हाँ बिल्कुल बना लें. R is K Q1 Q2 over potential energy. So what is K? 4 pi into permittivity of free space. तो R हम फाइंड कर रहे हैं. 4 pi times 8.85 times 10 to the power minus 12. Q1 1.6 times 10 to the power minus 19. This is also Q2, so squared over potential energy. 5.1 electron volts का क्या मतलब होता है? The charge of an electron. 1.6 times 10 to the power of negative 19 multiplied. Okay, you're not going to use the negative sign here. Can you solve this?
Is the answer correct?
Sorry, that was the answer. 3.489 should be 8.85 times 10 times 10 to the minus 12 times 4 pi minus 19 plus 12 minus 19. Assume calculate this again because I think I applied the correct formula, but the answer should be then open the markings. In the meantime, you try to do it again.
Yup, answer यही आ रहा है.
To answer marking scheme, then it's 2.8 times 10 to the power of minus 10 Newton. अच्छा, I want to do it separately. पहले तो 4 pi times 8.85 times 10 to the power minus 12 और उसके बाद 4 pi multiply कर दो. फिर इसका आंसर, write it down. Tell me the answer for this. Check my calculator.
This is the answer for 4.28 point. Would you value a first part key?
So the answer that I'm getting is even different than yours, but it's
Can
closer
you
to the.
scroll up a little? वो नजर नहीं आ रहा मुझे. Yeah, just a minute.
Pretty close now. 2.18 times 10 power negative 11 is the answer I'm getting. Let me pause the recording.